Yours is to sit down and. Okay, colleagues, we are starting. We have chemistry. And a very interesting thing about chemistry is that chemistry was supposed to be in mathematics. He left mathematics running within a week and decided that he wants to be alone in this TCOP of chemistry. I think that the group was too big for him. So, yeah, so the gangster paradise person from Gauteng province is the chemistry, Mr. Siabulela Mukebe, who will take us through this TCOP of chemistry, colleagues. So give a round of applause to him. Thank you.
All right. Good morning, colleagues. Okay. Okay. As introduced, my name is Siabulela Mukebe, and I'm going to be presenting about a topic under chemistry. So the topic that I chose is a topic under chemistry in grade 12. Right. So I'll start by showing you the overview of the presentation itself. So my presentation is going to mainly focus on acid-base titrations, and the point is to show how we can integrate simulations and virtual labs in the teaching of titrations, which is a section in physical science under chemical change, right? So I'll then move on to explain the rationale as to why I decided to choose this topic. Then from there, I'll speak to the alignment of this whole presentation to the CAPS document, because I think that is also very important, given the fact that we are in the South African context. And then I'll show my virtual lab demonstrations, and lastly, we'll look at issues of gender and inclusivity. Okay, so the first point that I want to make is that we want to advocate for virtual labs in a South African context, not only because of the fact that we are now in the fourth industrial revolution and the fact that everyone is now obsessed about technology, AI, and all that, but simply because of our systemic challenges that we have, and as a result that end up affecting the performance of our schools. So one of those would be the limited laboratory infrastructure, and then we look at things like the cost of maintaining a lab itself. It's very, very expensive to maintain a lab because the equipment in a laboratory is expensive itself, and also to find the right technicians who actually understand how to handle those things very well, that is also costly. So we look at things like the availability of data. Availability of data is also a challenge. And so on the right side of my slides, I speak about some of the mitigating ways in which virtual labs and simulations can help alleviate these problems. And one of those would be the fact that virtual labs or simulations are available offline, right? So what that means is that a teacher can download it, and then it's saved on the teacher's desktop or laptop, and then the teacher can be able to demonstrate it using a projector, right? So even if the classroom is too big or it has a lot of learners, right, but the teacher can still be able to use this. And you don't actually need an IT specialist to be able to work with virtual labs and simulations. If a teacher understands the content that they want to teach and they understand how to integrate it in the lesson that they want to deliver, and therefore it makes things much more easy for learners to also benefit from the lesson itself. So now I want to talk about my rationale as to why I decided to choose acid-based titration. So as stipulated before, that acid-based titration is a topic that is under chemical change, right? And it's assessed in paper 2, and it's mainly about 55% of the content in grade 12. And also, again, because the equipment that is needed to actually teach titrations is itself expensive. It's not like these other areas of chemistry. Like, for example, being able to buy hydrochloric acid or sodium hydroxide, that is quite expensive. So it's much more easier to teach those concepts using virtual labs and simulations. And I also thought of some of the concerns that have to do with those chemicals. So for example, if you look at sulfuric acid is one of the strongest acids, and it's corrosive. So if learners don't handle it well, and if the teacher is maybe distracted during a lesson, that can cause serious problems. So you can easily teach that using virtual labs and simulations without putting yourself in trouble as a teacher, because as much as we want to teach the learners, but we also don't want to teach them in such a way that we increase the likelihood of being in trouble as teachers. So there's also some high-level algebraic manipulations that have to do with teaching acid-based titrations, because you're looking at things like concentration and moles and all that. So it's much more easier, again, to teach those things using simulations and virtual labs. So the CAPS document speaks to 3 aims, right, of teaching physical science in South Africa. And one of that would be doing science. So if learners actually manipulate those variables using the simulation, they are actually doing the science, right? And number 2, learners have to know the science, right? So a virtual lab is important in that regard, because in a virtual lab does not only encapsulate the phenomenon, but it actually allows learners to perform the experiment itself. So it's different from the simulation in that regard. It doesn't simplify things too much. It actually enables them to actually work with different apparatus. So for example, they can handle a burette, not physically, but virtually. They can look at a burette, they can see what a funnel looks like, they can see what a flask look like. So, and also we have science in society as part of the aims. So we do have simulations that actually deal with how to use all this knowledge in society. So for example, in a province like Gauteng, you'll find that rivers or waters are affected by some of the chemicals from the mines, right? And as a result, that changes the pH of the water. So if you want learners, or another example would be that for a farmer, it's very important to understand the pH of the soil, right? So you can actually show the learners how to actually check that pH, but doing so using your simulations. So this is how the CAPS document aims are actually linked to what we're going to discuss today. So I have 3 different types of demonstrations that I want, but I'm mostly going to focus on the first 2. Firstly, because the first 2 are free, right? So these first 2 are free, and then this one you have to pay a subscription. So these 2 are the ones that can actually cater for most of our schools in South Africa. And the nicest thing about these things is that a teacher or learners don't actually have to have a desktop or a laptop or anything of that sort. They can actually use their smartphones to actually do this thing, right? And not all of them have to have the smartphone. If one of them has a smartphone, you can group them into groups and make sure that you assign roles in such a way that all of them are actually benefiting from the lesson itself. So the first one is the FET simulation. The FET simulation, the reason why I want to use this one is because it doesn't actually teach learners how to perform the titration. But what it does is it teaches them the difference, for example, between a weak acid and a strong acid, a weak base and a strong base, because they also need to understand that in a microscopic level in order for them to be able to understand how it will then be affected by something like titration, right? And then in a chem collective is not a simulation. This is a virtual lab. So this is where we actually going to perform the experiment itself. So then here I recorded my demonstration of this. So please watch and listen.
Hello folks. Alright, so in this video I'm going to show you how to access the PET simulation so that we can be able to compare the differences between us. Hello folks. So now we're going to use Chem Collective to
Sorry guys, I'm trying to zoom this thing and it's far. Oh, okay.
Alright, so in this video I'm going to show you how to access the PET simulation so that we can be able to compare the differences between a strong and weak acid, because this is one of those concepts that are difficult sometimes or confusing for learners to understand, right? So I'm going to search PHET dot Colorado .edu and then enter. Now one of the great things about PET interactive simulation is that they have multiple languages. So for example, I'll go to on simulations, and if you go to all simulations, I want to start by showing you that this is available in different languages. Right. So if I click on local and then English, click on that, and you can see that these are multiple languages, including Isiposa, right? Isiposa, so Isiposa, Isizulu, and things like that. So that's one of the nicest Afrikaans. That's one of the nicest things about this simulation. It has multiple languages, which makes it much more accessible to a larger population. Right. So that's the first thing. And another important thing that I want to show you is that if we scroll down and we scroll now, these are various simulations. For now, we don't want to concern ourselves with that. If I click on offline access, which is obviously going to be important in our South African context, given the fact that we sometimes experience things like load shedding and power cuts. Right. So if I click on the tick, right, then you see, so you can be able to download it for your Windows or your Mac OS. Then for learners that may not have access to a laptop or a desktop, whatever the case might be, they can also download the app through Google Play. Right? It's available for Android phones, tablets, and Chromebooks. Right? And then those that are owning an iPhone, they can also download it in the App Store. So really, it's accessible in that regard. It's accessible. So without wasting any much time, and now I want to search the simulation that we want to concern ourselves with. So you see, I just typed acid and it showed me acid-based solutions. This is exactly what I'm looking for. Okay. So scrolling down. So I'm going to click on introduction, right? Intro. Okay. So if I click on intro, this is what I'm going to see on my screen. So this is my strong acid, and this is how it looks like. And again, if maybe you've already started your simulation, but for some reason you decide that you want to change the language, you can always stick here, and then this will take you to maybe isiZulu if you want isiZulu or any other language, Afrikaans or Sotho or any other language. Right? But anyway, so this is my strong acid. Now, if I want to change maybe the concentration of my acid, you click on my solutions, and yeah, I want my concentration to be at 0.1 there, right? So my molarity is 0.1 there, so that is what I want. So,
Okay. The video is too long, so now I'm going to move on to Chem Collective, where I'm actually going to perform the titration. Right, so, yeah.
so now we're going to use Chem Collective to actually perform those titrations. Right. So first thing first is to find Chem Collective. So we first need to find Chem Collective. Chemcollective.org. And enter. Right. Now this is how that page looks like. And so I'm going to click on acid-base chemistry. Then from there, you go on acid-base titrations. Determine the concentration of hydrochloric acid using a standardized sodium hydroxide solution. Oh, I want this one. So here we want to perform this titration, and we want to find the concentration of an unknown hydrochloric solution using sodium hydroxide and sodium KHP. Right now, first thing that we're going to do here is to actually weigh our KHP. And remember, the reason why we're using KHP is because we can't really trust sodium hydroxide because sodium hydroxide is hygroscopic. So really, it means that approximate one molarity, we can't trust it. So we actually need to use KHP. And the nicest thing about KHP is that, remember, KHP stands for potassium hydrogen phthalate. The nicest thing is that their ratio is 1:1 with sodium hydroxide. So let's begin. So I took out my scale, and then now I need to weigh. So I'm going to click on glassware, then other, then I add my weighing board. That's a weighing board right there. You see the mess of the weighing board. That's the mess. And let's go back to your stockroom. Stockroom solutions. Now I want to weigh my KHP, potassium hydrogen phthalate. I want about 5 grams of this. You have to take it and you bring it closer to there. Then you're going to see this thing coming out. So we want to weigh about 5 grams of this. So after writing 5 there, click on pour. So you see it tells you that 5.00 grams has been transferred. Then done. So now that I weight my potassium hydrogen phthalate, I can delete it now. Remove it. So, sure. Then, the next step, I'll take my flask. Right.
Yeah, I think I've demonstrated how to use that thing. The video is just too long, so for the sake of time, I want to move on to another slide. So, the takeaway of this is that you can see that we can actually teach an acid-base titration using both a simulation and a virtual lab. A simulation helps in that it shows your learners the differences between a weak solution and a strong solution. And that, with that knowledge, they can then understand what is happening when we actually perform the titration. So the video is too long, but when you perform the titration, it gets to a point where when you swell your flask, there's a color change there. And the color change, we normally call it the equivalence point. And so those are some of the things that you can actually explain using that. So, but in order for us to be able to link these two things, what is also important from my point of view as a teacher is that you need to create a worksheet that actually scaffolds learners into doing that. Because if you can just give them these two platforms, as much as they are important, they won't be able to actually get the gist of what is actually happening here. So you have to create your lesson plan in such a way that you guide them as to what is actually happening. And one of the benefits of this is to actually create your worksheet and make them deliberately make mistakes. So you want them to learn what is called error spotting. So you want them to learn from their mistakes. The nicest thing is that here they won't waste any chemicals. So if they make the mistake, you then ask them questions on the basis of the mistake that they make. Why is this wrong? How did you come about this? And then how can you prevent this from happening? Things like that. So virtual labs mitigate the effects caused by the digital divide in education. Siyabulela. Thank you. Oh, questions?
No questions. Is there any question for chemistry? Chemistry is the last baby on the block that came in last week, leaving mathematics, running to chemistry. It was interesting with our chemistry colleague that the fact that he's explaining to say that the chemical, you won't have the spill within the classroom or the lab, the physical lab. You're not going to see the spill. You're not going to see those accidents happening where some of the learners that we have, maybe they are they're physically impaired or anything. People don't want to, even the smell of the chemical. So I think those are the advantages that I think he showed us to say, this one helps with some of us. Like, no, I have chronic sinuses like my breadwinner here in front of me, CEO. Won't be able to be, will go into that chemistry class, no problem with the virtual lab, instead of saying that, I can't go in there, the smell is too much. But now she can actually be able to go in there because we are utilizing virtual lab. So thank you so much for the chemistry group, but one person within the chemistry. Colleagues, we are now going to the fun part. We've heard the terminologies that are so hectic and all of that. I think it is too hectic terminology, especially when it comes to the real STEM. So we are stepping out of the real STEM. We are going to the STEAM. We are going to the exciting STEAM. I think STEAM, all of you are going to enjoy the exciting STEAM because of you are in STEM. So the STEAM, the A in that STEM is going to be so interesting that you're going to even want to use those simulations to also assist, because some of our colleagues that are there, they are able to use the actual ones that are the homes to show us how they can do it. So I think the next one is coding and robotics, if I'm not mistaken. Yes. So coding and robotics, the first person that we have is online, but I don't know if we can show it online because I can see it here, but I cannot see it here. Do you have it there? Okay. So maybe you can run the presentation this side, but we want to see her. That's the thing. We would like to see her on the board, the coding and robotics. But I think while we are sorting it out, the first, it is her, Miss Putiragupala. She's our eldest, the citizen there she is. I'm happy I can see you, Maragupala. I'm excited that you are here. I'm excited to see you, that you were able to connect. She wanted to be with us in this room. Like I say, she's a retired principal from Limpopo. She has been with us. She's the top class. We know when you say that for virtual labs and everything else that we are doing, it says she's in the top tier. She completes her task early. Even the certificate, she's the first one to even get it at her 70 plus. I don't want to expose your age. At the 70 plus years, she's able to do that. But she's not doing it alone. She is on this COP, community of practice. We also have, why am I echoing? Okay, we also have Mr. Vutsi from KZN who will come in with his presentation afterwards. So therefore, colleagues, I want to officially now hand over to Mam Putiragupala, our techno gogo in South Africa. That's what we call a techno granny. Yes, it's techno granny. That's what we call her in South Africa. And she is she's a recipient of the Baobab of the President of South Africa. So she's this one is not sleeping. She's a techno person par excellence. So because I'm hearing myself speak, I have a problem. I hope that we can hear you. Maragopala, can you hear us? We can hear you, we can see the presentation. Yes. Now I think it's better. They can just increase the volume. Can you speak? Again? Good morning. I'm muted. You've muted me. Yeah, all right. Can you just switch on the microphone? Please switch it on. We can hear you. We can hear you.